we do research on proteins misfolding diseases, which really are quite terrible diseases that affect millions of people, including Alzheimer's and Parkinson. So I really like the possibility of contributing towards finding a cure. We mainly work on Alzheimer's disease and Parkinson's disease. So these diseases are characterized by the abnormal aggregation of proteins in the brain, which eventually kill neurons. So what we're trying to establish is why these proteins start behaving in this dysregulated manner, and we are trying to find ways to prevent them from doing so. What we hope is to have an impact in two ways. The first way is, of course, we would like to find therapies to treat these diseases, which are still incurable for the most part. So finding drugs would be of tremendous help for the patients and their families, which at the moment have essentially no options. And the second type of impact is about diagnostics, because as we cannot cure yet these diseases, we cannot even diagnose them, at least not in a very accurate manner. And this is also preventing the progress towards treating them. In terms of drug discovery, we are working mainly on finding small molecules that can block the process of aggregation and prevent the formation of these toxic clumps of proteins which are highly neurotoxic. We are working on small molecules because these drugs have to get to the brain, and the small molecules are particularly capable of crossing the blood-brain barrier, which otherwise protects the brain from substances from outside. Another project which is related to diagnostics, which I'm very hopeful about, is the development of antibodies to detect the smallest among these aggregates, which are called protein oligomers, because these are the main cause of neuronal death. I mean, it's extremely difficult to detect these oligomers because they are very small and transient. So we have developed a new way of discovering antibodies, which is based on computational rational design, which enables us to solve problems which otherwise have been traditionally extremely hard. I think we are extremely interdisciplinary. These are very complex problems. So literally, we have researchers that span across all disciplines: mathematics, physics, chemistry, to molecular biology and medicine. When I arrived, I was coming from Oxford, so I had my culture shock already about originally I'm from Italy, and then I was a postdoc in Israel before coming to the UK. So, well, certainly a climate shock, if not a cultural one. So the Center for Misfolding Diseases, where we do our research, is hosted in the New Chemistry of Health building. And this is a very interesting experiment because the building also has an incubator space. And for this reason, it hosts spin-out companies from the department. So there is really a smooth transition between academic research and industrial applications. So we'll see where we go, but this is a very exciting new enterprise, which we hope will inspire similar initiatives elsewhere.